All right, let's dive right in. Today, we're pulling back the curtain on something that runs silently behind so many of the apps you use every single day: Java performance. It's that invisible magic that decides if an app feels lightning fast or if it just makes you wait. So let's get into the secrets of building incredibly fast applications. You know the feeling, right? We've all been there. You tap an icon. One app just pops open instantly, but the other one gives you that dreaded spinning wheel. That little loading icon. That's not just bad luck. It's usually a sign that there's a serious engineering puzzle being solved, or not solved, deep behind the scenes. On one hand, you've got that snappy, responsive app that feels like an extension of your thoughts. It just works. And on the other, you have the slow, clunky one that kind of tests your patience. Well, the secret ingredient that separates those two is almost always brilliant performance tuning, especially when you're dealing with a powerhouse language like Java. Okay, so Section 1, the need for speed. Let's talk about why performance is, well, everything. Think about it. From the games on your phone to the most complex corporate systems, Java is one of the key engines driving our digital world. And in that world, performance is king. It completely shapes how we feel about an app, and honestly, whether a business sinks or swims. Java's ability to perform at a massive scale, that's exactly why it's been a go-to for developers for decades. All right, Section 2, inside the Java machine. Let's take a journey into the JVM. So, time to pop the hood. This is where the real action happens, the Java Virtual Machine, or JVM. You can think of it as the brain and the heart of any Java program. It has two absolutely critical jobs. First, it has to skillfully manage all the application's memory. And second, it has to execute the code efficiently, no matter what kind of computer or phone it's running on. Now, to get all that work done, the JVM keeps memory neatly organized into two main zones. First, you've got the heap. Just picture a big open workshop where all the pieces of the application, the objects, are stored. Then you have the stack, which is more like a super organized to-do list. It keeps a perfect record of which tasks or methods are running at any given moment. So moving on to Section 3, finding the performance leaks, this is all about hunting down those pesky bottlenecks. You know, even the most powerful engines can spring a leak. And one of the sneakiest, most common problems is what's called a memory leak. I want you to imagine a sink that's just slowly, almost invisibly, overflowing. That's what a memory leak does. The app holds on to memory it doesn't need anymore, getting slower and slower until poof, it crashes. And here's the crazy part. These leaks often start with what look like tiny mistakes. A developer opens a file to get some data, but then forgets to write the little piece of code that says, okay, we're done, close the file. Or maybe they create a temporary cache for data that just grows and grows and grows with no limit, until it eats up all the available memory. Okay, so if memory can get this cluttered and messy, how on earth does Java deal with it? Well, it turns out the JVM has its own private, built-in, fully automated cleanup crew. And this process is called garbage collection. It's absolutely essential for keeping an app running smoothly. It basically works in 3 simple steps. First, it marks. It goes through and identifies every single object that's still being used. Then it sweeps, getting rid of all the junk that wasn't marked. And finally, it compacts. Everything that's left, tidying up the memory to make room and keep things efficient. Which brings us to our 4th section, writing smarter, faster code. This is the developer's toolkit. See, good developers can't just rely on the automated stuff. High-performance code is all about making smart choices. Here's a classic example. If you're building a long string of text, just using a plus sign over and over is incredibly wasteful. It actually creates a brand new throwaway object every single time. The pro move? Using something called a string builder. It's such a small change in the code, but it can make a massive difference in performance. And that same idea that there's always a trade-off applies to how you store your data. For instance, an array list is blazing fast if you just need to read data a lot. But if your app is constantly adding and removing things from the middle of a list, a linked list is way, way more efficient. Choosing the right tool for the specific job you're doing is absolutely critical for speed. And a lot of the time, an app's biggest bottleneck isn't even in the Java code itself. It's in how it talks to a database. So making that conversation faster is huge. For example, instead of sending the same kind of query over and over, developers use what are called prepared statements. This lets the database figure out the request just once. It's like giving it a shortcut, saving precious milliseconds on every single database call. So for our last section, let's look at performance in the wild. How does Java actually power some of the world's biggest companies? Now that we've seen some of the techniques, let's look at the results. I want you to just take a look at this number, 330 million. Any ideas what that might be? That is how many people use one single massive scale application every single month. And that application is built on high-performance Java. Handling that kind of traffic is only possible because of the constant tuning and optimization we've been talking about. And you can see these examples everywhere. That enormous streaming system that delivers your favorite shows on Netflix, that relies heavily on optimized Java. So many classic games, from RuneScape to Bejeweled, were built with it. This is the kind of tech that makes it possible for global products to work seamlessly for millions and millions of users all at once. So, in the end, all of this hard work, all this clever engineering, it all boils down to a pretty simple truth. Optimizing Java isn't just some techie thing. It leads directly to faster apps, lower costs for businesses, and most importantly, experiences for you and me that just feel great to use. And that kind of leaves us with one final thought to chew on. As our software and our digital world get more and more complex, the hunt for performance never really stops. It just moves to new, more interesting battlegrounds. Which really makes you wonder, where's the next bottleneck hiding? Thanks for joining us on The Explainer.